the smart grid real-time monitoring and analysis using DSP. See, smart grid is an advanced power electrical system that integrates modern communication technologies, sensors and digital signal processing unit that ensures the reliability and accuracy of the system. See, in this case study, we are using the smart grid by using real-time monitoring and analysis and also control the electricity of the signal. See, various sensors and smart power meters such as current, voltage, frequency and power consumption to monitoring and controlling of electrical signals. See, in this case study, we are applying the DSP algorithms, how we are integrating into a smart grid real-time monitoring and analysis. Let us discuss briefly.
A smart grid is a modern electricity system which can be used in a communication system like a digital system processing and also a sensor, and it can be used to improve efficiency and also reliability, whereas the traditional power grids we have only sends the electricity from the thermal power plants to the homes, whereas a smart grid which can monitor the real-time electricity system, and then smart meters on the sensor can collect the data from the thermal power plants. So the data includes the current, voltage and the frequency. The system can be analyzed by using a digital system processing, in whereas it can also found the fault and also predict the problem, and it can be used through many managing companies. In the traditional, old power have many problems because it can check quickly, so the faults are found late. So the power transmission may reduce faster, so it can lose the transmission. So it can use in a solar and wind. It also changes the electricity, so we need the smart grid system.
Now I am going to say about the objective of the system. The main objective of the smart grid signal analyzing and monitoring system, which includes to monitor the electrical devices in a real time, comes across the different parts of the power grid. It also detects the faults and abnormalities of the power supply at a later stage. It is used to improve the system reliability and maintain the stability of the electrical grid. It reduces energy losses and maintain the stability of the power grid. Analyze the current, voltage, frequency signals by using digital signal process algorithms.
Next one, this is a smart grid is an advanced electrical power system. What are all the challenges we are going to face is nothing but lack of real-time monitoring, that is lagging in real-time monitoring and analysis and delayed fault detection. See, to detect the faults such as we are using the DSP algorithms for fault detection, and also power quality issues and energy losses during transmission. By using this system architecture, we are going to analyze the sensors and smart meters. See, sensors and smart meters is nothing but to analyze the voltage, current, frequency and power consumption, right? And also we can using the data acquisition system. See, data acquisition system is nothing but to remove the unwanted disturbances from the signal, right? This is nothing but your data acquisition system. And also we are using the communication networks. See, communication networks is of your wireless communication, fiber optics. We can select the data sheets from transmission from your, that can convert the information into your signal for transmission during the electrical system process.
I am going to explain about the system architecture. So, the smart grid monitoring system, which has several parts which work together to collect, process and to analyze the electrical data. So, the first is sensors and smart meters. So, sensors which are placed in different locations to measure the electrical values like voltage, current and frequencies. And smart meters are installed in the consumer locations to monitor the electricity usage on the real time. The next is data acquisition system. The electrical signals are collected by the sensors which are an analog signal. So the analog signals are converted into a digital form by using analog to digital converters. So after the conversion, the digital data which are sent to the processing unit for the process. The next is communication network. So the communication technologies such as wireless networks, fiber optics and IoT systems which send the collected data to the central monitoring station. The next is control and monitoring system. So the process data will be displayed on the monitoring dashboards. So the users can collect the information to check the system performance.
Next, I am going to explain about the signal processing techniques that is used in power grid systems. First, digital system processing plays a crucial role in the power grid systems. First, there are 5 types. First one is the digital filters. The digital filters is used to reduce the noise and unwanted distortion that is occurred in the power grid systems. Next is the fast Fourier transform, which is used to detect the harmonic dislocations in the power grid systems and also in the power grid systems. Next is the wavelet transforms. The wavelet analysis, it is used to identify the minute details in the waves of the signal that is came from the power grid systems. Next is the load prediction system, which is used to predict the future consumption of the power for the power grids and also use it in a proper way. Next is the fault detection analysis, where it is used to detect the faults in the line to ground circuits, short circuits, and also in the power grid systems to prevent the short circuits in the systems.
Next, the application of smart grid signal monitoring. Basically, the smart grid signal monitoring systems are widely used in modern power systems. It has real-time power system monitoring, and it is used to detect the fault and emergency prevention, and it analyzes the power system quality. It has renewable energy integration, and it is used in smart city energy management.
In this smart grid power system, DSP plays a vital role in this for ensures the power quality monitoring system. See, first we are using it as your DAC, data acquisition system, which can process from your analog signals into digital signals with the help of filtering process. See, filtering is nothing but you have to analyze the frequency component with the help of infinite impulse response filter and a finite impulse response filter. How the filtering techniques can be incorporated in this smart grid power quality control system means to detect the fault identifications by using the fast Fourier transform. We are removing the disturbances that can be converted into frequency signal with the help of fast Fourier transform. And also we are using it as your digital filtering. See, digital filtering is nothing but we can remove the unwanted noises or disturbances from the power quality monitoring system, and also we can using the wavelet transform for sudden changes in the remove the sudden changes in the power system. We are using the wavelet transform, and also we are using the fault detection algorithms. Why we are using the fault detection algorithms here means we are using the stuck at 0 fault, stuck at 1 fault. Why we are using means to remove the unwanted disturbances during the smart grid power quality analysis and system.
And next one is advantages of the system. It helps the power system to work more safely and smoothly. It helps to detect the fault in the power system quickly. It improves energy management efficiency, so that we can reduce the power loss during the power transmission and power distribution. And also it helps to monitor the voltage, current, frequency and power quality. And it supports the integration of renewable resources like wind and solar energy. Next one is challenges and limitations. It requires high initial cost to set up the infrastructure, and that's the risk of cybersecurity attack in communication network. So that we need a skilled expert to analyze and process the signal. And also the system generates a large amount of data which must be managed. For this also we need a skilled experts. So to overcome all this we need a proper system design and communication technology.
Let us conclude the smart grid is an advanced power electrical system. By applying digital signal processing techniques into smart grid system, which can produce an efficient and accurate, reliable and power system. Why we are using means by integrating all these techniques under system architecture. We are using the techniques is nothing but digital filtering, fast Fourier transform, wavelet transform, fault detection techniques, and also we can using with the help of these sensors and smart sensors, data acquisition system, communication networks, ESP units and control and monitoring system. By integrating all these architecture and techniques into DSP to a smart grid power system, it ensures a reliable and efficient power system. Thank you.